back, everyone. So we're looking today at balancing redox reactions. There are two methods that we're going to go through. 7.2 has the main half reaction method first, and then actually the activity that is on page 450 we're actually going to go through as well, because that tells you the second method of balancing. Okay, so just a little recap here. So when you are assigning oxidation numbers, right, so this goes back to the lesson beforehand, right, so you have to start getting comfortable with that because obviously the first step is recognizing what is reducing and what is oxidizing, right? So zinc goes from 0 to +2, so that means that this is losing 2 electrons, right, so it is being oxidized. We could even say zinc is the reducing agent, if you remember that. And copper is going from +1 to 0. So that means that each copper is, gaining. Yeah, I spelled that wrong. But gaining 1 electron each, right? Which means it's being reduced, which means that copper ions are the oxidizing agent. Okay. So when we write out a reaction total, like this is the overall reaction here, we can actually write that as two separate half reactions. So a half reaction is actually exactly these two that are written. So it's showing just the species that is oxidized on the reactant and product side, and the species that is reducing on the reactant and product side. Now, it is also showing, of course, the electrons. So if electrons are being lost, they should be on the product side. It's very similar to, if you remember when we were writing out enthalpy equations, right? So if it was an exothermic reaction and energy is lost, it was written on the product side, right? So same thing, if an electron is gained, we would have that on the reactant side, right? And of course, we would have to say how many. So because zinc went from 0 to 2, we know that it lost 2. Copper went from +1 to 0, which means that we gained 1. Okay, so this is a summarized step-by-step procedure of how you're going to go about balancing chemical reactions this way, or redox. So this is a nice little summary, but obviously it doesn't really make any sense until we start doing some examples. So these are the steps for balancing half reactions under acidic or neutral conditions. Okay, so acidic and neutral are balanced in the same way. So the first thing we're going to do is we're going to balance everything else other than hydrogens and oxygens. So if there's chromium, if there's fluorine, if there's whatever, other than hydrogen, oxygen, we're going to balance those first. Then what we're going to do is we're going to look at oxygen. So the order will matter here. So oxygen is next, and we balance by adding molecules of water. So it's very different. You're not going to change the coefficient in front of the molecules to make them balanced. You're going to add water. So for every 1 oxygen that you require, you're going to add a water, because every oxygen has every water has 1 oxygen, sorry. Okay? When you balance your hydrogens next, you're going to do so by adding hydrogen ions. Okay, so you're not changing coefficients here. You're literally adding 1 hydrogen ion. For every hydrogen you need, you're going to add a hydrogen ion. And of course, you're then going to add electrons to make sure that the charge is balanced, which will make sense again when we do this. So this is the order of operations. It's like, ooh-wee, I don't know. So it's other atoms, oxygen, you balance with water, hydrogen with hydrogen ions, and then electrons. So other atoms, oxygen, hydrogen, electrons. Okay, now when you're doing it under basic conditions, it has different rules. We're going to go over this. I'll come back to this page when we do it. But literally, it's all the same until the very end. You're going to then add a hydroxide ion to both sides of the equation in order to neutralize all of the hydrogens. So don't worry about this so much. We'll come back to this. Mainly, the one thing you should know is, like, let's say you have 2 hydrogens. you would add 2 hydroxides in order to neutralize that to make 2 waters. Okay, so if something is a basic condition, we should not have any hydrogens left behind, right? Okay, so let's take a look here. So balance the following half reactions. Assume that the reaction occur in acidic unless specified. In each case, indicate whether it is an oxidation or reduction. Okay, so these first two doesn't say anything, so we're going to assume this is acid, right? Okay, so let's talk about it. Let's look at what's changing. So we have a elemental form going to a positive 3 ion. So because we're going from 0 to +3, it's losing electrons, so we know this is going to be an oxidation half reaction, right? Now to balance this, let's do the order. So it was this. So other atoms first. So there's 1 SM on both sides. That's done. There's no oxygens. There's no hydrogens. And then for electrons, we have to show, because it's lost 3 electrons, all we really have to do is add the +3 electrons on the product side. Okay, so that part's done. For this next one, we have a little bit more that we're doing. So I'm just going to rewrite this out. Actually, let's assign oxidation numbers. So oxygen is -2, right? So in total there, that's -6. And nitrogen has to be +5 for that to work to -1. Hydrogen is +1, so that's +4, which means nitrogen is -3. So nitrogen is going from +5 to -3. So actually, this is reduction for sure, and it's gaining 8 electrons. It's going from +5 all the way down to -3. So let's write this out bigger so we can work with this here. All right, so all right, so other atoms first. So the only thing that's here that's not hydrogen, oxygen is nitrogen. So that's already done. There's 1 and 1. Then we're going to do our oxygens. So we have 3 oxygens on the reactant side. So I need to add 3 waters to the product side to get 3 oxygens. So that's what we mean by add waters. Then we're going to look at our hydrogens. I have 4, actually I have 0 on the reactant side, but I have 4 plus 6 coming from the product. So that's 10. So that means I need to add 10 hydrogen ions to the reactant side to make sure that that is balanced. Like, so 10 hydrogens, 10 hydrogens. Okay, so now this last step is looking at the electrons. So this is a little bit more complex. So in order for the electron charge to balance, the total charge on the reactant side should equal the total charge on the product side, okay? So how you would do this is you just basically add up all of the charges on the left and all of the charges on the right. Now, we know that it's going to gain 8 electrons, okay, but it might not always work out this way. Like, the method I'm going to show you right here for balancing the charge will always work, okay? So 10 positive ones, this is like positive 10, right? And then we have -1 coming from the NO3. So in total, on the reactant side, we have +9, right? NH4 plus, there's 1 positive 1. And then, of course, waters are neutral. So on the product side, it's a total of +1. So now you're going to say, okay, well, to go from +9 to +1, that means you have to gain 8 electrons in order to get that down to 1. So that's how we know we're going to add +8 electrons to the reactant side. Okay? Now, in this case, it worked out because we already knew it was gaining 8 from the original point. But you don't even have to do this work at the beginning. You can just simply balance it looking at the other atoms, oxygen, hydrogens, and do electron counts at the very, very end. It should work out to the same value no matter what. Okay? All right, so let's take a look at our first basic solution. Actually, yeah, before we get to the basic ones, let's do number 4, okay? So let's do our OOE. We'll do our electrons at the end. I'll show you what I mean by that. Okay, so we're going to do our other atoms first. So we're leaving oxygen out, but we need a 2 here because there's 2 sulfurs. So that's this part here. Oxygens. We have 3 oxygens on the left, and we have 8 on the right. So that means we have to add 5 waters to get 5 more. So 5 plus 3 is 8 oxygens. Hydrogens, we just added some in. We have 10 hydrogens from the waters, so we need 10 hydrogen ions. So hydrogen is done. So now let's do our overall charges. So our reactant side, we have 0 from the water and -2 from our S2O3, so it's a total of -2. Going to, so 0 for, oh my gosh, what am I saying, 0? Mamma mia. There are 2 -2s, so this is -4 from the SO4s, and then we have +10 from the 10 hydrogens. So in total here, we have +6. So in order to go from -2 to +6, that means that we'll have to have lost 8 electrons, right? So hopefully that makes sense. So on the product side, we're going to have 8 electrons. So I'm just going to clean this up. So the final balanced reaction would be this. Sorry, my dog's making weird noises. Arrow. 2SO4, -2, sorry, it's making me laugh now, plus 10 hydrogens plus 8 electrons. Okay, so it looks super complex if you just like look at it now, but if you practice it and do the what am I saying? OOHE, the steps, you will get it every time. Okay, so let's talk about basics now. Actually, I'm going to clean this up. You've written that down, but because I might need more space. I just don't want to. Oh. All right, so let's take a look up here. So we're going to do the same thing. The only difference is there's going to be an extra step at the end that we're going to do, okay? So other atoms is just iodine. So then that's done, 1 and 1. Oxygens, we have 4 versus 3. So we know we're going to need to add a water to the product side, right, to get it to be 4 and 4. Hydrogen, we have 2 on the product side. We need 2 on the reactant side to make our hydrogens equal. Now for the electrons, we have, let's do our products versus reactants. So our reactants, we have +2 and -1. So we have a total of +1 on the reactant side, and we have -1 and then 0, so we have a total of -1 on the product side. So to go from +1 to -1, what's happening here is we are gaining 2 electrons, right? So we're going to have +2 electrons. So I'm just going to clean this up a little bit. It's a little bit messy just for what we have. So we have 2 hydrogen ions plus IO4, IO3 plus water plus 2 electrons. Okay, so that's what we have so far. So let's backtrack and look at, well, what's different here? So after we balance the charges, so we did our H, oh my goodness, I keep putting H first. OOHE, do not put H first. You're not going to get the right answer. So after all of that's done, so we've done 1, 2, 3, 4. We're going to now add hydroxide to both sides in order to neutralize the hydrogen ion. So what that means is the same number of hydrogens that we just added, we're going to add an equal number of hydroxides, but not just to one side, to both sides. So I'm going to have 2 hydroxides added and 2 hydroxides added to both sides. The reason why is because we want these two to neutralize. The 2 hydroxides and 2 hydrogens make 2 waters. Okay, let's take a look at this in the next part.